tests. 2 out of 9, I think. Hold on, parting C. P-A-R-T-I-N-G-C. But then there's the direct and the other comparison tests. And then there's technically ratio and root tests. There's kind of 10 tests. Two of the letters have 2. Like R is ratio and root, and then C is comparison, but it's direct and indirect. So we have 10 tests, but this is 2 out of them, so that's good. But we only looked at 1 yesterday. It had to do with a geometric series and only geometric series, and you can't use the test if it's not a geometric series. This is endeavor number. Help me out. I don't remember. What was the special converging sequences? It was 12? James is checking. You guys can back him up. We're thinking this is 13. Oh, this is 12. What'd you have as 12, Kathy? Oh, what'd you have as 11? Oh, what do you have in 11, James?
11, I have the special converging sequences, and 12, I have the improper integral case where you have like 1 over x of p, and then that's 1.
Oh, the special p series one. Yeah. Okay, there we go. Then this is 13. Okay. So special converging is 11, and then 1 over x to the p is 12, and this one's 13. Got it. Yeah, it could have been you were absent that day. That's possible. All right, cool kids, ready to have fun? We have 1 more test, and we're going to learn that other said test, but every time we learn a new test, we're going to practice with that test. Now, hold on. Let's wait until the end of the section, the end of today. Okay, here we go. You ready? The first thing you have to do is figure out what this is and what test we're going to use. What do you mean it's geometric? Ah, got it. There's a common ratio. The common ratio is 1/2, so therefore we are going to use geo-series test. Yes, and I'll tell you why. Geo-series, but not right now. Geo-series, write it out. Why? Because that's the test we're about to use. Okay, cool. You're clarifying? No. You're determining which test you're going to use. Geo-series. Got it. Go. So what do we do with geo-series? Well, we test the R. And what is the R? 1/2. Is R in between 1 and -1? Oh, that's annoying. We have to write a lot of stuff. How about this? Can we do this instead? How about, is that okay? Because the absolute value of R is talking about his magnitude being less than 1. So whether positive or negative, who cares? He has to be less than a magnitude of 1. So this is ultimately the exact same thing as between -1 and 1. And what conclusion can we make as a result of seeing that? What does the geo-series say if R is between 1 and -1? Pause. Converge or diverge? Thank you. And not just converging, but converging to, now, Justin, what were you saying?
So 1 over minus r.
Wouldn't that be 1 over 1/2, aka 2? Now pause. What did I do? First term. Where'd the 1 minus come from? 1/2 come from? Perfect. Are we good? Ah, because geometric series test says for any geometric series where you have a common ratio multiplying to get each and every term after that, the infinite geometric series will converge to a constant as long as R is in between 1 and -1. And all of that comes back to what I rushed at the end of yesterday, this old school S sub n formula. Remember, a series converges if its partial sums converge. So geometric and arithmetic, there are actually little formulas from pre-cal as to how to find the 10th, the 100th, the 1000th, the millionth sum. You can plug into your S sub n formula and check it. The only possible way this can converge to a constant is if that goes to 0. Because that's where my n is, right? And whenever I raise something to a power, it grows, it grows, it grows. No, the only time raising to a higher and higher power will shrink is if you have a fractional. So check it. The only time that R sub n will go to 0 is if we have 1 over, right? If we have 1/2 or 1/3, or we have some quantity that's less than 1. Because then the bottom would win. And we would end up, because it was that number whose magnitude is, there we go, is small. So if you were to right now plug in, what's something that's almost 1 but a little bit under? 99 100ths. If you were to plug in 0.99 and raise it 10th to the 100th to the 1000th in your calculator to the millionth, but it's almost 1. Guess what it's going to do? Shrink. Anything that has a magnitude less than 1 is going to shrink. What would 1 to the millionth be? Still 1. It doesn't shrink. What would 2 to the millionth be? It's going to go to infinity. So r cannot be anything outside the bounds of 1 and -1 and still let this converge. Now that's the y to the test, but the nice thing is, it's just a test. So as long as r is something in between 1 and -1, sweet, always converging for a geoseries and always converging to the formula a sub 1 over 1 minus r. So therefore, I think I just stated the test. Is that what I just stated?
Yeah, but you said it always converges if it
As long as r is in between 1 and -1.
So just to make sure, so if it was equal to 1, then it would still go to infinity, right? Because it would keep adding the same number.
Right. Your sum would just keep ever expanding. Does that make sense? How about number 2? Geoseries? Is the absolute value of r less than 1? Perfect. So therefore I can say it converges. But when I say converges to, don't I need to know the first term, which is 1? I need to know the ratio, which Ariane just told me is -1/3. You guys going to have fun with the mental math? Did you get 3/4 yet?
my question is this how easy the homework is going to be, or
For this test. This chapter, no. This section, yes.
This is the only test in this section?
No. There are 2 tests this section. But the other test isn't much harder.
I meant like geometric series tests.
There's only 1 geoseries test. But there's a second test in this section's homework that's almost as easy as geoseries. And then it gets fun. Number 3. It's written differently. Pause. Haven't we already done something like this before? What am I doing? I'm writing out the first few terms of the series, which is the exact same thing as doing it for the sequence. Plug in 1, plug in 2, plug in 3.
So the sequence is a series in this one?
A series is
A series is a sum of a sequence. Right? There's commas. Instead of commas, there are pluses. Oh, but you won't soon. All right, so now what? Geoseries. Not in a totally bad way. What's my R?
1.
So therefore less than 1, right? So therefore converging, right?
Yes.
And therefore converging to. What do I need to know?
The first number.
And what's the first term? It's not a focus. What's the first term? All over. 1 minus, what's my R?
1/2.
So therefore my final answer is 1, right?
Yes. I love it for period.
So is the n only on the 2 because they simplified?
You could think of it that way. It could have been 1 to the n over 2 to the n, but yeah, math problem would never write that. Yeah. Ready, set, your turn, go. For 4 and 5. -5/4?
Okay, that's all we need, right?
Yeah, write out a few terms. Because remember, if there are 10 different convergence divergence tests, not every single series is going to be geo, right? So are there going to be some series that might look geo and aren't geo?
Can we
So you have to make sure that you can recognize the geo when they come. I'm saying in this homework, it's like, oh, it's either geo or it's the other one. But at the end, it's going to be like, well, it's 1 of 10 tests. I wonder which one I should use.
Do we have to memorize all of them? We just have to know all the features.
Which is why I'm doing a quiz part way through the test, so that we can have a little practice of, okay, what if we just have a series and we have all these different possible cases?
Calculus is like, it's understanding, but now we have to memorize stuff. I don't like memorize.
You had to memorize derivative and integral rules at some point, didn't you?
Yeah, but it's
You
not
can
really
work it out.
memorized now.
Not all the trig ones. The integral of cosecant?
It wasn't 10
Okay.
tests.
We have so much memorized at this point.
Thanks, Riley.
All right.
Keep it chill. You guys got it, right?
We have like 70 for final so lesson 1. I don't know. Yes, it's open.
Do you guys realize what your common ratio is? Do you guys agree? The 5 didn't get raised to powers. If it did, we'd be in trouble. Hey, do you guys realize that we can see the ratio based on the ends?
Yes.
Do you also realize it's going to be geometric as long as there's no additional plus or minus apart from the multiplication of something with ends? Do you also realize it's going to be geometric as long as we only have multiplication by numbers to ends? If I put a +1, is this going to be good? Nope, it's not a geoseries anymore.
What is it called?
Non-geometric series. It's called other. Neither. Not arithmetic or geometric.
I love that.
So, what do we got? Geoseries. My R, is he good?
Yes.
Sweet. So therefore I know the series converges to -1, right?
Oh, yeah.
So it's going to be 1 minus -1/4, aka 1 plus the fourth, aka 5/4, aka converging to -1.
I know. Oh my goodness. So easy.
You guys already playing around with number 5? Tangent of pi over 4? Isn't that root 2 over? No, it's not. It's 1. Because it's root 2 over 2 over root 2 over 2, right? Or square root of 3 over 3, 1 square root of 3. 1 is the pi over 4, right? So isn't this,
They're sickos.
we can use the geometric series. And you saying it diverges because it makes sense in my head is super dangerous. I mean, you're actually right on this one. But how can you prove it with the test? Geoseries. What's my R?
1.
Oh. Isn't that absolutely wrong?
Wait, on the AP. Usually make these like FAQs.
Not an entire FRQ. But here, Filio. Whether or not it's a part of an FRQ, there are always multiple choice questions, and the multiple choice questions give you multiple series asking which of them converge or diverge, and you have to do multiple tests to multiple series in one multiple choice question.
What?
It's not very often that I see one series converge diverge being one whole multiple choice. Usually it's like, here, I'll give you a few and you find the converging.
Oh, it's like
So I need you to go
1 and
fast.
2, 1 and 3.
Got it. Which is why we're going to need to get fast eventually.
Oh, can we play a game with it? Wanna get
It'll be a while, but sure. Okay, what do we got?
Oh.
Wait, so it's -1 to the n minus -1.
Right? Even power starting off, right? What's my R? So what am I going to say? Goes to 0. Goes to 1? Nope. Diverges, which is what our oscillating trick should also tell us, right? Sorry. Because oscillating, remember? Oh, sorry, Maggie, you weren't here yesterday. Partial sums. Isn't the first partial sum going to be 1, then 0, then 1, then 0, then 1? It was one that we did in our calculator yesterday, and we're like, oh, hey, it's converging because it's forever confused. Series. Sweet, let's go.
Chapter 10.
And we would cry because he would find 1 out of like 30. Okay, so maybe 2.
I'll take my chance.
Them aren't good odds. Endeavor, number 14. Divergence test. Wait, I thought the whole chapter was called convergence divergence. Why is this one named the divergence, otherwise known as the nth term test? Because it's the only test out of all of them that only proves divergence and cannot prove convergence. Do you guys see how there's a big old purple line under something? Do you think that big old purple line is there for a reason? Do you see how there's some things written in caps? We only if. Okay, what do you see going on in this test? Do you see a series? What do you see? A sequence. Do you see a sequence? I see a sequence. See? It could be an n. If you like n better, go ahead and do n going to infinity of a sub n. The AP can use k's and c's and i's and n's. It can use whatever it wants. Just be fair. If you want to do the limit as n goes to infinity of a sub n for the nth term, totally fine. The person I stole it from used k's. So you can call it the kth term test, but that's awkward. No one ever says that. It's the nth term test. Okay, the limit as n goes to infinity of a sub n. It's saying, look at the sequence. Thank you. Is the sequence of terms going to 0 or not? If the sequence of terms is not approaching 0, whether it's a number or infinity, if it's approaching anything non-zero, what can we say? This is what can be proven. The rest of the card is basically warning you that nothing else can be proven by this limit. The only result of the limit that can prove anything is if the limit is not 0, the series diverges. If the limit is 0, what does it say? The series may or may not converge, aka if the limit of the nth term equals 0, we don't know anything, test fails. So the only thing that this test can tell us is if the limit of the sequence is 0, diverge, done! It's actually one of the best tests ever if you see it at the very beginning. But if the limit equals 0 of the sequence, we know what? Got it. Remember how yesterday we did that one in our calculator of 1 over x or 1 over k or 1 over n, or I don't remember what we called him. 1 over somebody. This guy. Remember how I said that he diverges? Remember how I showed... You don't remember. Remember how our calculator plugged in 10, plugged in 50, plugged in 100, and it kept on growing? And I gave you a heads up that if you kept on plugging in, it would keep on growing, and it would never actually end up start fixing decimals and getting closer and closer and closer to any one quantity. Long story short, that's why. This is 1/2 plus 1/3 plus 1/4 plus 1/5 plus 1/6. It all it took was the equal 0. This must converge, and it doesn't. Can I explain why? Not really beyond the fact that it doesn't. It's called the simple harmonic series. And it's where your mind starts to get confused.
Can we just do an example though where it was like 1/2 plus 1/4?
That converges. Everything.
Okay.
No, wait a sec. What's actually the difference?
The terms.
So literally just the fact that it goes from 1/2 to 1/4 instead of 1/2 to 1/3.
1 over n squared, 1 over n cubed, 1 over n to the fourth all converge. 1 over n does not. 1 over the square root of n does not. 1 over, hey, it has to do with that forever card, endeavor card number 12, the 1 over x to the p. If p is greater than 1, the improper integral converges if p is less than 1. So we could see in the improper integrals by solving out and taking like the ln and then seeing what happens. Like you can see in that, apply that idea here. Just your brain doesn't like it here because it's like, wait, they look the same. But they're not. Their integrals weren't the same either. So the integral of 1 over x diverged, whereas the integral of 1 over x squared from 0 to infinity converged. I can't give you a non-mathematical look, it's true reason.
And then how does this tie back to the phrasing that equals 0 and equals 0?
Oh, because I just showed you one where the limit of the sequence of terms does equal 0. The terms will forever decrease, and yet the series diverges. So coming back to the test, just because the limit of the sequence of terms goes to 0, just because the terms get smaller and smaller, does not necessarily mean that the series will converge.
Okay. My next question is, how do you use this like in math?
Here we go. How do we use it in math? We'll go back to the other page in a second. You look at a series and you say, hey, do you converge or diverge? Oh, you mean like in further application?
Well, not that, but like.
Okay, good, because I don't have an answer for it right now.
But it says the limit as n approaches infinity can't equal 0.
No. Pause. Let's practice. Let's practice. So, geoseries. Is this a geoseries? 1 plus 4 plus 9 plus 16. Is that geo? No. It's not geo. Because it's times 4 times, not 4. Okay, that doesn't work. Plus 3 plus 5. That doesn't work either. There's a pattern, but no. So geoseries, why am I saying that? Because if geoseries worked, we'd just do that. Oh, it doesn't work. Okay, nth term test. What's the limit? As n goes to infinity of n squared, which is not 0. Hey, guess what? By the nth term test, this thing diverges. Application. But what about number 2? You could plug in if you really want to. You'd have x over ln of 1, and then you'd have x squared over ln. You'd have x cubed over
why is it
ln of 3.
Shouldn't it be numbers? Oh, never mind.
What's the limit as n goes to infinity for any x? Yeah, infinity over infinity, that makes sense, right? What does that mean? Zoomed out too much, Los Santos.
So the special converging, I'm just kidding. Got it.
Would you guys like it better if I put a b instead? Does that make a little more sense? The x isn't the variable, the n is the variable. It makes sense that you guys were confused. But so we could do b instead if you want. Ln of n. But we could take derivatives. If we did, 1 over n, oh, poor little guy, now he's helping the other team. He's so weak. Only one derivative and he's gone, right? Whereas he, the derivative is b to the n, ln of b. Long story short, not 0. You guys have way too much fun. Nth term diverges. Does that make sense? It's not even like he goes to 0. One derivative and he's already helping the other. Yeah.
Are there examples when the limit goes to like 2?
Oh, this one's nice. Look, the limit exists. The sequence converges. It does, but the series doesn't. Why?
Oh my gosh, I'm saying a lot of words.
Well,
It's a lot of vocabulary.
There's no R.
No R, so not geometric. What's the limit? Yay! The sequence converges, but sequence.
Not series.
I say not series. What does the limit have to be to even open up the possibility of this converging? 0. To open up the possibility, not guarantee. The limit equals anything that's not 0. Nth term says diverges.
So you do this when it's not geometric.
Yes. Well, technically, to be honest, in the grand scheme of things, when we're doing convergence tests, on the test, after we've learned all 10, we've practiced all 10, we've had a quiz halfway in between so that we're not like totally overwhelmed when we get to the one with all 10, I would say, technically, check it, the chart. You have an infinite series. The first thing I would say you should always do is check the nth term test. Why? Nth term test right away could say diverge, stop, don't try anything. Or, okay, maybe converge, test fails, keep going. So we learned the geo first because he's technically pre-cal, technically. If R is in between 1 and -1. You just didn't necessarily see it like that. My class did. Sorry, maybe you guys didn't. It was chapter 11. 10? 11 was three-dimensional vectors that we skipped. 10. Nope. 9. 10 was probability. I don't know what chapter it was. Anyway, so Maggie, hold on, pause. Or everybody, if you see an infinite series, first thing, limit. If the limit equals 0, I don't know. Try something else. If the limit equals constant, diverges. If the limit equals infinity, you're oscillating, or who knows, divergent. The limit has to be 0 to even try to keep going. So how about this guy? How about this guy? How about this guy? He's 2 plus 4 plus 8 plus 16 plus. If you keep adding bigger numbers, it's going to diverge to a constant. However, how do I show that? Easy. Limit as n goes to infinity of 2 to the n is not 0, right? How about the next one?
I'm gonna guess diverges.
it's going to go to 0 because the factorials goes faster.
Remember, factorial is stronger than anything else?
Yeah, that's right.
So I'm not even going to plug in because I'm like, that's gross. Instead, I'm just going to come over here and say the limit as n goes to infinity of e to the 2n. Oh, equals 0.
Wow.
You just got stuck.
It may
We-
not
We
just
know nothing.
We know nothing.
No, nothing.
May or may not.
How about number 6? I know, struggle. No, your brain's going to do that, though, because the sequence converges, not series.
How do you know that? Oh, bottom line says 0.
Yeah. Factorial wins because of the special converging sequences. Well, we don't have the special converging sequences yet. We're just now seeing factorials. And for those of you guys who are like, what's the practical application? Factorials can be dealt with here, whereas in the rest of calculus, so far, we haven't seen a factorial because we couldn't deal with it. Math, probability, and then there's a little exclamation point.
Is that even a series?
The factorial?
No, number 6.
Oh, yeah.
They said no pluses.
It's not G. But wait, the degrees are tied, though. So even though we don't want to do L'Hopital's because we have no idea how to derive a factorial, we can still say, oh, degrees are tied. Let me. So what do we know? Diverge. Good, Eric. Nth term test, diverge.
So it's called nth term test or divergence?
Either way. The nth term proves divergence. Divergence is only proved by the nth term.
Well, I'm gonna guess this one's divergent. Just say it.
Yeah, you think so?
Yeah.
But the problem is, can this test prove it? Why? What's the limit? What do we have to say? I haven't told you one. Could there very possibly be some sort of fill in the blank? Because this forever quiz, this endeavor quiz is just going to be a big old handout, front and back, fill in the blank of all the different tests once we get there. Fill in the blank, you want them all from memory, fill in the blank of the different tests. But could a blank be, we know nothing? Yes. Could I be proud of you if you say we know nothing? Yes. Be careful. Be careful. What is this? Section 9.2 OT. Make sure that you scroll to the second page of the handout PDF in Google Classroom. And where can you guys go to check the odds? Thanks. Where can you go to check the odds? CalcChat, the black one with the gold ring. All right, you guys good?
Last one with the gold ring.
That's a question. I think I figured out like the term, but it might be because like with the series, is it like it can possibly converge to equal 0 because eventually you'd be adding 0, so then it'd be like it converge, the series would converge. Is that not why?
Sequence, sure. Series, no.
I'm thinking like
You have to go back. I think in my brain, what's helped me most as far as having somewhat of an understanding is something that you guys don't question when we do it. But when we take the improper integral from 0 to infinity of 1 over, how on earth does this converge and this not? This helps my brain. Because they're both right. They're both so similar. Really? Like this one diverges and that one doesn't? Like it's basically the same question. But here we can actually see the math as far as using ln of b minus, like that goes to infinity very slowly. Well, sorry, that's impossible. There we go. That goes to infinity very slowly. So it's going to very slowly approach infinity, but this one's approaching infinity, whereas this one is not. So wrap your mind around this if you can, and it helps for that. So this is as mind-boggling as that was, just you guys didn't question it because the integrand, or the antiderivative, showed it to you. And so you just accepted it without realizing the implications and how tricky it actually is to wrap your mind around it. Sorry, guys, that was the bell. You guys can go ahead and go. I love that you're all staying, though. Totally thought you guys would have just left and been, like, talking. Oh, that's weird. Huh? You see that? What? Answer key to what? Oh. I was like,